So what's the key thing that stands out to me in this question? Well, I can see the term sound wave in there, so now I'm going to have to say stuff about that. And the question is asking, describe how hitting the rod causes sound wave to travel along the inside of the rod. So I know if they're saying sound wave, that's the suspicious thing that stands out to me in there. I'm going to go, yeah, it's a longitudinal wave. So the first thing that I'm going to say is sound wave is longitudinal. So I'm just going to say there, sound wave is longitudinal. Again, now I'm going to show the examiner I know what is meant by longitudinal wave. So that means the particles, I've got to make sure that I mention the word particles, oscillate. So I still have used another keyword in there, in the direction of energy of the wave, or travel of energy of the wave, or energy travel in the direction of energy travel. So playing it safe by using all of these keywords. I've said longitudinal, oscillate, I've said energy travel. Okay, now I think I've probably got 2 marks for this because I'm using the word longitudinal, I'm using oscillate, I'm saying what it is. But just to be safe, because it's saying describe how that causes it to travel along, I might as well just say as well, because the particles are oscillating, I'm going to say they're hitting neighboring particles, causing them to oscillate as well. And now I'm pretty sure that I've got everything, so I'll just obviously show why I've got those marks in here. So I've identified that it was a sound wave first, and I just made sure that I'm using all of those keywords that I can possibly use. I've said longitudinal here. I've said about the oscillate. It's always in the direction of energy travel that I'm saying. I've just got to make sure I know those definitions. This question will come up on the exam. I'm just going to make sure I get the mark. Okay, so what stands out to me now? So it's about refraction, and it's actually telling me it's being quite nice here, and it's telling me that the sound travels slower in air than it does in water. So it doesn't have to tell you that. You are expected to know that sound waves travel slower in air than they do in water because there's fewer particles and sound needs particles, whereas EM waves like light, radio waves, all of those travel faster in air because they don't need particles and there's fewer particles to get in their way. So that's the way that you can think about it. So if it's a wave that needs particles, when there's more particles, it's always going to travel faster. If it doesn't need particles, then if there's particles that get in the way, so it travels slower. So if this was a real exam, like in the year that you're sitting it, they might not have this information here that they're being nice for whoever in 2019, the people who were lucky enough to sit it then. But when you see that's about refraction, so that's the key thing that I spotted first. The first thing that I'm going to do is just show that I know that is it going to speed up or slow down first, and then I should know if it speeds up, which way does it go compared to normal. If it slows down, which way does it go? So even if it didn't say this part over here, the fact that I know it's a sound wave and I can see here it's going from water to air, straight away I just know, okay, yeah, fair enough, it's a sound wave, therefore it's going to slow down. Now I also need to remember that if waves slow down, they're going to go towards the normal. So if it was going to go straight, it would just carry on going like that. But obviously that's not the case. So it goes towards the normal. So I'll just rub that out so it don't look confusing. So it shouldn't be there. It should be carrying on going this way towards the normal, so anywhere towards the normal. And I know, yeah, that's definitely right there. So it's 2 mark question. I'm getting 1 mark for showing that it's refracting probably, or showing the direction which it is, rather than reflection in the bottom corner or something like that. So I just know it's going to refract. And the other one is towards a normal, and possibly they might penalize me for not drawing the arrow on there. So I'm going to make sure that I've drawn the arrow as well. So we've got a calculation question here, but it's an unfamiliar equation that I can see here. So it's just showing, have I got the skills to do things? Have I got math skills that I can do stuff with an unfamiliar equation? Now this is kind of a nice one because it's one with a constant in there. It's about proportionality or relationships between 2 variables, and you can always basically do this in the same way. So you're always going to get a question about some kind of constant or some kind of relationship between 2 things, and just always look to do it in this manner. So when I can see something like this, that word constant on there, I know I've got that equation. Basically, or probably what I'm going to have to do is I've got 2 sets of data. One set of data is going to be complete, and then one set of data is going to be incomplete. Now, from the set of complete data, I've got to work out the k first. So I'm just going to write the formula. Well, check the units as well. But if it's a constant one, to be fair, I don't actually need to do the units for this because the units for the constant will cancel out. So I'm going to say speed of sound equals k over the square root of the density. Now I'm just going to do it for this one. So when the speed of sound is 331, I've got k over there, square root of the density, square root of 1.29. And then the answer to this one, I'll put this in the calculator. Oh, sorry, I've got to rearrange it first. So I'll say k equals 331 times the square root of 1.29. And like I've said before on calculation questions, if you're stuck on how to do calculations, then ask me about it. Or to be fair, I'm going to make a video at some point about just like calculation questions if people are struggling with that. So yeah, you can have a look at that as well. So now I've worked out k, and it's saying k equals 375.9437. Write down the long number of the calculator. Now, because I'm going to use this later, I'm not going to round this, but I'm going to show the examiner. I might even put a box around it just in case, I don't know, the examiner's tired and can't spot my working or something like that. I've worked out k. So I've got a mark for this one now. So now I'm just going to, because it's a constant, I can just put it back into that same equation. So I'm going to say speed of sound is equal to, well, instead of saying k now, I know it's a constant. So that's 375.9437 divided by square root of density. And now what am I looking for in this row? Because it's asking me there the speed of sound in warm air. Well, I can just put this into the equation now. So it's going to be this number that we've just written down, that we just worked out of k, divided by square root of d. Well, this is the one that I've got left. So square root of the density is 1.16. And I'm just going to put that in the calculator, divided by square root of 1.16. I'm always going to write the full number first. So 349.0549. And that's it. And then I would generally round to two significant figures, but this question is saying give your answer an appropriate number of significant figures. How do I know what's appropriate? Well, this is the three significant figures here. This is the three significant figures here. This is the three significant figures here. So therefore, my answer is going to have to be to three significant figures so that everything is matching. So my answer to three significant figures is 349. Now, as I was writing this one over here, I just remembered that, or I kind of realised that I'm just doing stuff quickly to make the video a little bit shorter, not writing out speed of sound, and I didn't write out full density. I just wrote D for density. But just to not be confusing, I could be using the symbol for density as well, which is rho. I'll write it up there. But I was just writing D as in I couldn't be bothered to write out density in full. But the symbol for density is this one over here. So the next question, the first thing that stands out to me is the graph again. So I just know, okay, I've seen a graph. I'm probably going to have to take some readings from there. I'm looking for an excuse to draw on this to show the examiner that I take readings from a graph. So let's take a look at the question. And it's saying use a scale and diagram to measure the wavelength of the wave. So the key word in there is obviously wavelength. So the examiner is testing me, do I know what is meant by the wavelength of the wave? And I know that it is the distance, the length of one wave basically. The distance between one peak to the next peak or one trough to the next trough and so on. Okay, so how can I do this? Well, one way that I can do it is I can just take the reading from, I should know the shape of one wavelength is this, so I can just see where this comes up, and that's a reading that I can take from there. If I get that reading right, I should be able to get the full marks for this question. What they might do sometimes in the exam is say the word accurately or something like that and expect you to go, look how many wavelengths there are here. So there's one that we've just done, and then there's two, and then there's another half, so 2.5 wavelengths. And this is showing me that 30 has got 2.5 wavelengths. So I could just, for this question, maybe do it for one, but the fact that this is a 2-mark question, I'm thinking maybe they want me to do the division thing by looking at the number of wavelengths and divide it by the number. So I'm showing the examiner I understand what is meant by a wavelength. So I can say 2.5 wavelengths is equal to 30 centimeters. And then if 2.5 wavelengths is equal to 30 centimeters, this is probably enough work in that I've done. But I could maybe even write it down, okay, 30 divided by 2.5, or one wavelength is going to be equal. So therefore one wavelength is going to be equal to 12 centimeters. Or like so we could say 30 divided by 12. 12 centimeters out, and I didn't need to do the conversion because I can see they're asking me for the answer in centimeters. So I've checked the axes that matches that, so I'm pretty happy with that. Okay, describe the motion of the cork. You should include how the cork moves relative to the direction of the travel of the wave. So the thing that's standing out to me here is why they're using this thing of the direction of the travel of the wave and about the motion. So the thing that I've realised that they're trying to test me on is about the fact that what type of wave is a water wave over here. So I know that a water wave is a transverse wave. Now, I might not get marked for this by saying that it's transverse, but it's a key word, so I might as well just say it. So I can just make that point there, the water is a transverse wave. And the cork's floating on the water, so I can say therefore the cork, and I'm going to again use the keyword oscillate, and because it's transverse, I'm going to say perpendicular to the direction of the wave. So I'm just showing the examiner that I know exactly what they want me to say. Basically, I've identified it's a transverse wave, and yeah, I've got that one right now. Okay, so part D, just a calculation question over here. Calculate the wave speed of it. So first thing I'm doing, looking for the units. Okay, the units are fine. I need a formula with speed in there, and they're giving me wavelength and frequency. So what's the formula that's got all of those things in there? It's going to be V equals F times lambda. And always, I'm just going to treat all formula questions the same way. So I'm looking for V, so I'm going to write down V first. The frequency, I put exactly where the frequency is. I'm not going to put them, 0.25 came first in the question, I'll write it first. That doesn't matter. What matters is what I wrote first in the formula. So I wrote F first. So here I've got to write the F first. And then there's lambda afterwards. So I've got to write the value for lambda afterwards. And as always, I've got a calculator in the exam, so I'm just going to make sure that I put this in my calculator, always write the full number off the calculator, so that's 0.375, and then round to 2, get in the habit of always round to 2 significant figures, so I'm going to say 0.38. Now I'm pretty happy that I've got 4 marks for this whole thing.